Welcome to Vision Plus and welcome back to Vision for Mathematics. We are looking at finding the length of the tangent from a point to a circle. Example 3 says that we are given two equations of a circle and the points where the tangent comes. Further, we have x squared plus y squared equals to 12. This is the circle, and then we have the tangent drawn from point 6, -1 to the circle. So what do we need to do? Let us sketch the circle to guide us. Then we say this is my tangent from which point? Point 6 and -1. So let me call this point B to make our work easier. Then let's call the point where the tangent meets the circle. Let's call it point A. We know that the center is in the middle and the radius is perpendicular to the tangent. Now, what are the coordinates of the center and what is the radius? They are going to help us in finding the length of the tangent. If you look at this equation, it is in the factorized form, yes, or if we shift this 12 this side, it becomes in the expanded form. It changes into expanded form. But if you see x squared plus y squared, it means that the coordinates of the center were 0, 0. That implies that if we are considering the factorized form, which is x minus a squared plus y minus b squared equals to r squared. This implies that r squared equals to 12. Okay, r squared equals to 12. That means r is root of 12 units. This is our radius, root of 12. Even when you consider it as in the expanded form, you can also get the same value of r. So after getting the value of r, now we are left with finding this length AB, which is the length of the tangent. But we cannot yet find it because we only have the radius, which is one side. So to get the length AB, we need to also know the length CB. We need to know the length CB. Now, how do you get the length CB? The length CB is the distance between 2 points, that is the center, and the point where the tangent is drawn. So let me call this x1, y1, x2, y2. Then we substitute in the formula that the length CB, which is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Then we substitute x2 is 6 minus x1 is 0 squared plus y2 is -1 minus y1 is 0. And then you press the calculator and get the length CB. 6 minus 0 squared plus -1 minus 0 squared, 37. So the length CB is root of 37 units. Now, the length CB here is root of 37 units. Now, since it is a right angle triangle, we can apply Pythagoras theorem. So when we apply Pythagoras theorem, which states that the sum of the squares of two shorter sides equals to the square of the longer side. So the two shorter sides are AB, AC. So we shall say AB squared plus AC squared equals to, now the longer side is CB squared. Then we substitute We know that AB squared is what we are looking for. We are looking for AB plus, what is AC? AC is root 12. So root of 12, but the formula says squared equals to CB. CB is root of 37, but the formula says squared. Therefore, from here, our AB now becomes, then you press the calculator, root of 37 minus root of 37 squared minus root 12 squared. I'm getting 5 units as AB. That is root of 37 squared minus root of 12 squared. Then you take the square root. I'm getting 5 units. So the distance from A to B is 5 units. Therefore, that is the length of the tangent. Therefore, the length of the tangent is 5 units. This is the tangent which is drawn from the point 6, -1 to the circle. So this is how we solve for part A. Let us go to part B. And going to part B has given us the equation of circle as x squared plus y squared minus 8x plus 4y plus 19 equals to 0. This is in the expanded form, as you can see clearly. This one was in two options. You can either consider it as the factorized form or the expanded form. But for the expanded form, you must carry 12 besides so that you equate it to 0. But this one is already equated to 0. So we can see that clearly it is in the expanded form. So we come and we scale the circle to guide us, and we say, assuming this is our tangent, from which point? From point -1 and 3. So let me call this point B to make our calculation simpler. But in some cases, the question can specify for you that the tangent drawn from point B with these coordinates, or point C, point P, or any letter that they are using. Let me call this point where the tangent meets the circle. Let me call it point A. This is the center, for which we have the radius perpendicular to the tangent, 90 degrees. So what are the coordinates of the center of this circle? You can get them from the equation. So you go on and find them, because we looked at how we can find the center from the given expanded equation. So in this case, I'm seeing 4 and -2. Those are the coordinates of the center, 4 and -2. Now let us find the radius so that it can help us find the length AB. This is the length of the tangent that we are looking for, length AB. How do we get the radius when you are given the expanded equation of a circle? In your knowledge, you have an equation that says a squared plus b squared minus r squared gives us c. What is c? C in this case is positive 19. So 19 equals, what is a? A is 4 squared plus what is b? B is -2 squared minus r squared. Then you work out and find the value of r. 4 squared plus -2 squared, and then minus 19. Take the square root. So I'm getting r as 1 unit. I'm getting r as 1. Let me prove again. 4 squared plus -2 squared minus 19. Yes. So r is 1. So this distance here from the center up to point A, where the tangent meets the circle, is 1. Now, what do we need now? We need the length AB. Since we have the distance CA, we can get the distance or length CB to help us find the length AB. Because it is a right angle triangle, we shall apply Pythagoras theorem. So the length CB, that is the distance between 2 points given by x2 minus x1 squared plus y2 minus y1 squared. And then you apply, you substitute for, let me call this x1, y1, x2, y2. Or you can call this one's y1, x1, and then this one's x2, y2. There's no problem. Shall get the same answers. So on substituting here, what is x2? x2 is -1 minus x1 is 4 squared plus what is y2 is 3 minus y1 -2 then squared. When you press the calculator, -1 minus 4 squared plus 3 minus -2 squared. So I'm getting CB as root of 50 units. So the length CB is root of 15 units. Now that we have the distance AC and CB and it is a right angle triangle, the properties of Pythagoras theorem apply. So applying Pythagoras theorem, we shall have, it says that the sum of the squares of two shorter sides equals to the square of the longest side. So the longest side is CB in this case. So we shall have AB squared plus AC squared, AB squared plus AC squared equals to CB squared. Then we substitute. So here we shall have AB squared plus what is AC? AC is 1. So we shall say 1 squared equals to what is CB? Root of 50 by the squared. Then you press the calculator and you find that AB, the line AB gives us, I'm saying 49, root of 49 is 7 units. Because root 50 squared minus 1 squared, then under root. So therefore, the length of the tangent will be the length of the tangent, which we have called AB, is 7 units. That means the distance from where the tangent was drawn to the point of tangency on the circle is 7 units.